Mesh and node analysis in AC circuits. Okay, so we all know how to solve and analyze circuits with mesh and node analysis method. We learned it for DC circuits, and the technique is exactly the same, but with we deal with impedance instead of impedance and phasor instead of resistance. So we start our mesh and node analysis by some examples for DC circuits. Here we have one example which we want to use mesh analysis to find output voltage V2 and input impedance ZI. Here is the circuit. This circuit has a dependent voltage source as well as independent voltage source. So the values, the voltage source is 10 with angle of 0. So this example gives us the values in phasors, which make it easier for us to analyze. We don't need to calculate the phasors. So the values are given in the phasors. So it's 200 ohm, J 250 ohms, negative J 500 ohms, 50 ohms, 2 V sub X, 400 ohms, Vx is the voltage across 400 ohms resistor, and V2 is the voltage difference at these 2 points, and Z in is like here, Z in or Zi. Okay, we want to find the Z in V2 for this circuit. Let's start to solve this circuit. The first thing we want to, the problem says use mesh analysis. So we need to go with mesh analysis. For mesh analysis, we know that we should define currents I1 and I2 and write KVL. Okay, so KVL mesh 1 and mesh 2. For mesh 1 we start from negative from 200 ohm resistor, so we will have 200. Let me just make it smaller to see all of them in one screen. So 200 I plus J 250 I1 plus 400 times I1 minus I2, which is equal to 10 with the angle of 0. The second loop will start from capacitor negative J 500 I2 plus 50 I2 plus 2Vx plus 400 I2 minus I1, which is equal to 0. Of course, we know that Vx is equal to 400 times I1 minus I2, and we replace this value in the second equation, and we will, as a result, we will have these two equations: 600 plus J250 I1 minus 400 I2, which is equal to 10 with the angle of 0. The second equation will be written in this form: 400 I1 plus negative 350 minus J 500 I2 is equal to 0. Okay, we put these values in a matrix. We can solve this equation with both matrix multiplication or substitution. We know that if in the matrix, if ax is equal to b, x is equal to ba minus 1, and so we can find x by matrix multiplication. Uh, so let's put in the matrix. So it's 600 plus J250 negative 400 negative 350 minus J500. In order to solve this matrix multiplication, the calculator has to have a complex matrix multiplication capability. So, or you can find some online websites that or some online resources that can multiply the complex matrices, and so we can just do this multiplication and find I1 and I2. So I1 and I2 will be equal to 10.8 minus J 11.1 milliamp, which is equal to, if we convert it to a polar, which is equal to 15.5 with the angle of negative 46 milli amp. I2 is negative 1.93 minus J 9.95 milliamp, which is equal to 10.1 with the angle of negative 101 milliamp. So we got I1 and I2, and in order to find V2, we need to multiply I2 by 50 and plus it and add it to Vx. So Vx itself is like 400 I1 minus I2. Okay, so we have 2Vx and we can find V2 based on this information. So let's do that. V2 is equal to 50, as I mentioned, I2 plus 2Vx, which is equal to 50 I2 plus 2. Instead of Vx, we replace it with its value, which is 400 I1 minus I2. If we solve this equation, we will get the value of 10.1 minus J 1.42 for the Vx, for the V2, which is equal to 10.2 with the angle of, I believe it should be like angle of -8 or something. I'm not sure about the angle. Let's just calculate the angle is arctangent of minus 1.42 over 10.1. Okay, so this one is V2 and Z in. For Z in, how we can find Z in? We know that if we look to this circuit from this point, from this dashed line, we know that the voltage, the total voltage over current will be equal to Z in. So if we have a current here, current, so we know that the voltage over the current divided by current is the impedance input. So we say Z in is voltage over I. What is IVS is like 10 with the angle of 0, and I. What is I? If you look to this circuit, we see that the I leaving the voltage source is same as I1. So we can simply say that 10 with the angle of 0 over I1 is the input impedance. So it's equal to 10 with the angle of 0 over I1 was 15.5 with the angle of negative 46 milliamp, which results in the Zn of 645 with the angle of 46 ohm, or 448 plus J 46 ohms. Okay, so if like in order to like for calculating Zn, let me explain it a little more. So let's say we have a voltage source V, and this voltage source is connected to like a black box. We don't know what is inside this box. There is tons of different elements. If somebody asks us to find the Zn, the input impedance of this box, input of impedance of box, the only thing we need to do is finding the current entering the box, and then we can replace this entire box with a Z equivalent, okay, and we can say Z in is equal to V over I. The voltage across, the voltage divided by current is the impedance. So instead of impedance equivalent, let me just write impedance, input impedance. Okay, so the only thing we need to do is finding the current entering the box and divide the voltage by that current, and it shows the input impedance. The same thing here in this example. So we considered entire this circuit as like a box that we have no idea what is inside it, and we don't care. In fact, the only thing we care is finding the current and the voltage. So the current is equal to I1, which we have the value, and we can say that the voltage over current is input impedance. Okay. The next example for mesh analysis, let's assume we have this circuit and we want to analyze the circuit. So we have plus minus 5 dependent current source, we have capacitor, we have inductor, we have resistor, we have another capacitor, and all of them are connected together like this, and we want to analyze the circuit and find like currents. The voltage source is 10 sine of 1000 t plus 120. The current source has a value of 2Vx, the dependent current source. The capacitor has a value of 1 microfarad. The inductor has a value of 100 millihenry. The resistor is 20 ohms with a voltage Vx across it. And the last capacitor has 5 microfarad. Okay, we want to solve this. First thing we notice is that the signal is in the form of sine, not cosine. We need to convert the AC signals in the form of cosine. Okay, so what should we do? We know trigonometry equations tells that sine of theta is equal to cosine of theta minus 90. We use this equation to convert it to cosine. So the Vs, let's say it is called Vs. Vs is equal to 10 cosine of 1000 t plus 120 minus 90, which is equal to 10 cosine of 1000 t plus 30 degree. Okay, so if we write it in the form of polar form of in the phasor form, it will be 10 with the angle of 30. Don't forget that omega is 1000. Okay, so we say V is equal to 10 with the angle of 30. For the resistor, for the capacitor, we need to calculate negative J over omega C. If we do these calculations, we will have negative J 1000. For inductor, the impedance is J omega L. If we multiply the terms, the final answer will be J 100. For this capacitor, Again, we find the impedance, negative j over omega c. The result is j, negative j 200, and that's it. Now we have all values in phasor, and it's time to solve the circuit. So we need to solve this circuit with mesh analysis. So I1, I2, I3. Okay, the first thing we should notice is that we have a special case, which is super mesh. Super mesh is when we have a current source between two meshes. So we should identify a super mesh, which now I'm showing it with this green arrow, and now it's time to write the equations. Okay, so super mesh, which is loop number 1 and 2, is 5I1 minus j 1000 I2 plus j 100 I2 plus 20 I2 minus I3 is equal to 10 with the angle of 30. Let's just double check. 5I1 minus J1000 I2 plus J100 I2 plus 20 times I2 minus I3 is equal to 10 with the angle of 30. That's fine. The constraint, we know that negative I1 plus I2 is equal to 2Vx. Okay, negative I1 plus I2, how? Here, I2 minus I1 is 2Vx. Okay, but what is Vx? Vx itself is equal to Vx is equal to 20 I2 minus I3. If we apply this Vx in this equation, we will have negative I1 plus I2 is equal to 40 I2 minus I3. So we got the first equation here, second equation here. Let's go ahead and find the third equation. The third equation is loop number 3, which tells negative 20 I2 no, sorry. Negative J 200 I3 plus 20 I3 minus I2 is equal to 0. And this one is the third equation. Now let's just rearrange all these three equations and show them in an organized form for I1 and I2 and I3. So first equation, we will have 5I1 plus 20 minus j 900 I2 minus 20 I3 is equal to 10 with the angle of 30. I1 plus 39 I2 minus 40 I3 is equal to 0. In the last equation, negative 20 I2 plus 20 minus J200 I3 is equal to 0. Now we can put all these three equations in matrix multiplication, and we will have 5 20 minus J 900 negative 20 1 39 negative 40 0 negative 20 20 minus J 200 multiplied by I1 I2 I3 is equal to 10 with the angle of 30, 0 and 0. And if we solve this matrix, which I recommend you to try to solve it with complex matrix multiplicators to see if you can get the same answers I'm showing you here. So I1 is 0.43 with the angle of negative 54.7, 0.011 with the angle of 131, and 0.001 with the angle of negative 144.6. And these are I1, I2, I3. Okay, so this one was a lecture on mesh analysis. The next lecture I will talk about node analysis.